say anything. Everybody got their thing. Some niggas make millions, other niggas make memes. I'm on the money routine. I don't want smoke, I want cream. I don't want no more comparisons. This is a marathon, and I'm aware I've been playing a bet from a lack of promotions. I never was one for the bragging and boasting. I guess I was hoping the music would speak for itself, but the people want everything else. Okay, no problem, I show up on every one album. You know what the outcome will be. I'm betting 1,000. It's got to the point that these rappers don't even like rapping with me. Fuck it, come on, nigga. 21 Savages hit me and told me he sent me a spot on the new record he got. He called it a lie.
I'm not dreaming, am I?
You're not.
Hello, everybody. How's it going? Hope everyone's having a fantastic day right now. Let's get this adjusted a little bit. So, yeah, welcome back to the stream. I hope you'll have a good time here, and I super appreciate. There's now been like a bunch of people giving me suggestions on how I can improve the stream, and I've been listening. So, one of the things is the use of background music. I've had background music in all of my streams, but someone mentioned, hey, you should add it. And then I was like, but I already have it. But then I figured out the volume was a little low. So, I have Cordio's jams playing in the back right now. I have them a little bit louder. If you think it's too loud, just let me know, and either in the chat or, just shoot me a message, and, we'll keep tweaking it till it's right, Also, another person mentioned to me, like, hey, I like interacting with chat, but the delay is brutal. It's like by the time I type something and send it over, the topic's already passed. So, turns out that's a setting. So, yeah, all I had to do was just go into the YouTube settings and set it to low latency. And now the chat delay should be greatly improved. As in, like, it's shorter now. It should be closer to actually live. So I'm pretty excited for today because one of the posts that I did just a few few days ago for Pi Day actually generated a lot of interest. And if I want to pull the Discord here, I'll show you. And actually, I'll say this. If you're watching my stream for the first time, first off, welcome. You're the best. Make sure to hit that subscribe button and hit the bell so you don't miss my later streams. Additionally, I have a community Discord, so I'll retrieve the link to that. And, I'd love to see you on there. We have a very vibrant community. We've had, a couple dozen people join over the past couple weeks that I've started streaming. Also throw my link tree in there, which is kind of like the catch-all link that has just all my social medias in it, right? So if you want to find my Instagram, Twitter, other stuff like that, that's the place to go. Oh, hey Danielle, good to see you. Welcome to the stream. You as well, Sebastian. He's been very consistent, so I'm super glad to see. I'm super glad to see both of you here, and yeah, I think this is gonna be super awesome. And let me pull up that live. I'm sorry, the Discord, which is on the live tab. But it's been popping off. I say that every time. But, we've had, conversation. Oh, I guess I should change the screens, right? There we go. There we go. So, lots of interest about the movement that I posted on Pi Day, which was the spirograph. Yeah, good to see you, man. I was just talking about, some of our conversation about this thing, and how I will not only be going over it, but I want to actually play around with it, because as you may know, if you've played with a spirograph before, there's many ways to set it up. Oh, Bree says hi. Yeah, tell her to say hi back. Yeah, Bree's the best. But I'm just so glad that y'all are watching, and means a ton to me. And additionally, so we'll be going over this, and also looking at Yaya's work. He's been doing an amazing job. I recall, if you may recall, we looked at this last stream when he did the animation of the camera spinning around Pi. It came out so amazing. And he's been showing it off, and he deserves every bit of attention that he gets for his work. But also very cool. And this is actually something I really haven't tried though, and it's animating lights in Solidworks. Apparently that's a thing that you can do. So you can see well, let me see if I can put show original, make that a little bit larger. There we go. So you see we have this cactus here, and you see he's just kind of mimicking the motion of the sun moving across this admittedly very small desert, but this is excellent work. Yeah, you should be very proud, and I love your creativity with this. I'm gonna have to try this on my own sometime too. So yeah, great inspiration. So again, in the chat I have the link to the Discord if you're not a member already. Also, Yaya showing the method to his madness, publishing some of the dimensions that he used to make the pie. Very, very beautiful work there. And what I love about your sketch here in particular is that, it's one thing to just go crazy with splines, but I can just see by inspection here that he uses mostly analytical geometry. Analytical meaning, lines, arcs, ellipses, just those basic types. I see only 2 style splines there. So it's not only looks very good, very accurate, but it's just a beautiful example of just generally efficient sketching. So, hats off to you there. Sebastian, hey Rob, do you know if 3D connection gadgets really worth it? 6 degrees of freedom mouse. Oh, that's an interesting thing to bring up. So, I'll catch you guys up if you haven't used it. So, what he's talking about, 3D connection with X's, I think. Oh, that is way spelled wrong. There we go. So 3D connection, they sell mice that look like this. So the idea being, you have this device on your left hand, assuming you're right-handed like I am. If you're right-handed and use, your regular mouse with your right hand, you'd have this in your left. So what you would do is you'd push this knob around. You can push it forward and backwards, side to side. You can twist it and also push it up and down. And what this does is that it links to the camera in Solidworks and allows you to rotate it very fluidly. So, now what do I think of it? I may not be the best person to ask because I don't use it. And I'll explain why. It's not because necessarily it's bad. So I'll tell you what I've heard about it first. I heard that it's an amazing investment. That, if you're a CAD designer, CAD engineer, and you're spending multiple hours a day on this, what I heard is that the people who buy this, find it very awkward at first. Like it has a bit of a learning curve to it. But once you get used to it, it's just like an extension of your body. Like I heard it's that good in terms of, being able to rotate your model exactly as you'd expect. So I think overall, I think these things are great. So why don't I use them? I don't use them because mainly I'm a CAD educator. I don't want to be using tools that the average computer user wouldn't already have, because I don't want to create the illusion that, oh, I must buy this mouse if I want to be like Rob and post models every day. It's not true. You can just do that with what comes out of the box with just a basic PC, mouse and keyboard. I have been interested in using it in the future though, but it's one of those things like if you don't have it, no biggie. If you can find one, maybe find a good deal on them. I'd say try it out. I've heard good things about it. Danielle saying she has used that mouse before. I really liked it, but haven't bought one myself. Yeah, I'm basically in the same boat. Like I've used it before, and I've never gotten to the point where it's been like, an extension of my body. As like, that's how someone literally described it. But yeah, I'm glad Danielle with the echoing here. It's just like, honestly, you don't need all the fanciest stuff. And for the longest time, I didn't have like my fancy computer with my nice IBM keyboard and stuff like that. Like you can be a good designer just by having like a basic laptop. So yeah, that's my whole spiel about it. But yeah, great question, Sebastian. But yeah, something I want to do here. So is there anything in here? Okay, no, just like Virus talking about his breakthrough here, saying that, oh, I didn't know you actually have to activate the motion add-in. That is a very common thing. I wish SolidWorks was a little bit better about that. About, they have this excellent tool, and I'm like 90% sure what I'm about to say is correct, but I believe SolidWorks Education Edition does include SolidWorks Motion. But many students don't use it because they don't see it in their add-ins. It's not activated. You have to activate it in your installation manager, then turn on the add-in, and then go to this menu to activate motion analysis, which will become very relevant soon because I'll be playing with the spirograph here in a minute. But yeah, that's not, that's mainly what's been popping on the server. Also, I think it was Virus that asked this question too. I literally couldn't find it anywhere, but I'm pretty sure I remember Virus asking me, what is the difference between CAD tech help and design advice? Because it's kind of the same thing, right? Like you just go in there and ask questions. So, what's the difference? The difference is, CAD tech help is mainly for the questions about software itself. So, in CAD tech help, you would ask the question, why can't I activate SolidWorks Motion? Or this mate isn't adding. Or I try and do this feature and this error message pops up. It's about the software. Design advice is mainly about your design itself, like taking the CAD out of it. So design advice would be for questions like, okay, I'm trying to bolt a metal sign to a wall. Do I use 4 small screws, 2 medium screws, or 1 big screw in the center? Right? That's the thing for design advice. It's like it's not really related to SolidWorks specifically. It's more related to mechanical design and those kinds of things. So I hope that clears that up a little bit. Alessio, if you have nothing, you will push yourself to the limits. Yeah, I think that's kind of true too. I just love pushing my just all my tools to the limit, especially SolidWorks, like pioneering stuff that a lot of people haven't seen before. Like what was very, very exciting to me was what was very exciting to me, if I go to my videos, is in my presentation for SolidWorks World, people just adored the tutorial to make this bouncy crate. Why do you need a bouncy crate in SolidWorks? Like, you don't really... Like, the amount of situations where you need this bouncy crate is very minimal. It's very rare to come up. But the act of understanding the theory behind how SolidWorks computes solids and then using that to your advantage to do whatever you want is super, super cool. And, for the longest time, when I was constructing my my presentation here, I was actually thinking about leaving it out because it's like, oh, it's less about the animation, but it's more about, part modeling itself. But, I left it in there, and I'm really glad I did because people tell me that it was like the highlight of their... people tell me it was the highlight of the presentation in many cases. So, yeah, be sure to check that out if that suits your fancy. And we might be using like similar techniques here when we play around with our what's it called? Spirograph. That thing. Yeah. Alright, so yeah, I think what I'll do first, and I think the modeling I'm going to do with the spirograph is not going to really count towards CAD model of the day, which is okay. I'll figure something simple to do towards the, or later in the stream, I guess. But yeah, because I thought of the spirograph idea like literally towards the end of the day because I was really thinking about like, okay, today's Pi Day. I gotta do something cool. But I also wanted to keep with the theme of March Madness of mechanical movements and mechanisms, right? So I was like thinking really hard. It's like, I don't want to do anything boring like two spur gears, like, everyone's seen that. But, I thought about, cycloids and like how they can be generated with like spirographs and other cool stuff like that. And, what I ended up doing was I just kind of randomly picked values. Like, okay, the ring gear is going to have 300 teeth. The, I guess the planet gear, technically. I said, okay, let's make that 96 teeth. And, let's put the spiral like this. And then when I ran the motion study, it turned out to basically generate a sunflower pattern. And I was really pleased with that. And I just kind of published it as is. But, I think this is going to be a good opportunity to really, like, play around with some values and see what kind of shapes we can get out of it. Alessio, SolidWorks is interesting also for the add-ons. You can do a million things in just one environment. For example, reverse engineering. Oh, totally agree. I think one of the main benefits of SolidWorks, and I think this comes out as a double-edged sword sometimes, and I'll explain what I mean by that is, for example, the integration between SolidWorks CAD modeling and SolidWorks simulation is so good. Like the fact that you can have a 3D model and then click this button here, do a basic simulation. Is it not right? Okay, just go to back to the CAD environment, make that thing a little thicker, and then hop back into the simulation just by clicking a tab, and then run it again. It's so wonderfully efficient. And when it works like that, it is just it's like chef's kiss, beautiful. Other things is I think with other softwares that has been quote unquote integrated, I think there's some work left to be done. Like I think the integration between SolidWorks and SolidWorks Visualize can be improved in my opinion. Like I think many people, even ones that don't know the history of SolidWorks Visualize, can tell that it was not previously a SolidWorks product. For those of you who don't know, SolidWorks Visualize used to be Bunk Speed, which is, for it's to its credit, a fantastic photorealistic render. It's great. Once you get to know how to use it, you can create some amazing scenes and amazing renders with it. But the integration is like very awkward between SolidWorks parts and SolidWorks Visualize. Like honestly, they're like so different that I wish they would have just called it the So Systems Visualize, because putting slapping the SolidWorks name on it is just kind of overselling an integration that is really not there. Now, ever since that change happened in 2015, it's massively improved. Like they've got the integration with it, a lot better. You can bring in lights, finally, all sorts of appearances over, and it's been better. But I think SolidWorks overall does a pretty great job with that. But let's take a look at this doodad. So one of the things I need to do, and one of the things that going back to what I said about basically just picked a bunch of random values. I used the SolidWorks standard gear set and then saved it out as a dumb solid so I can do all of these like modifications to it. I want to see if I can get let's see. I want to see if we can get the ability to change different size gears, just to see what kind of effect that will have. So I think that's the thing I'll work on. I'll work on first. Well, actually, no. Let's just see what I got here, right? Let's just go over what I did. Yeah, I know I'm all over the place, but yeah, let's review what I did for Pi Day. So yeah, first thing you need to turn on SolidWorks Motion, because the spiral graph is done with the plots and results function of motion analysis. So you do need to have motion analysis, the SolidWorks Premium thing going on. It is what it is, but yeah, if you have it, make sure you actually turn it on so you can actually see the wonderful thing. So, pulling back the curtain a little bit, in reality, when you have one of these spiral graphs in real life, it's kind of up to the user that, when you put the pencil into the little gear and move it along the track, that you're moving the pencil in such a way that, this gear doesn't just pop out and just ruin your drawing, right? But SolidWorks is not smart like that. You have to kind of tell it, go along this path, right? But the way I accomplished it was like this. I just drew a random linkage that was connected with a concentric to the origin of the assembly, and then the centroid of the gear. And then I just applied a motor to this linkage. The linkage moves and then takes the gear with it. And then I have the teeth. I don't use a gear mate at all. I actually use solid body contact. Just because I have that available with me, you know, I just have it. The ratio pretty much sets itself. If I hit calculate, let's see. Yeah, so we still got our paths here. So the way this works, and what I can even do is add a new path. So I'll show you how that's done. You go to results and plot, select a category, displacement, velocity, acceleration, and the first item here is trace path. And in this box, you select a vertex, a point, or a sketch point that represents what you want to keep track of. So we could say maybe this little corner. Where does that thing go? And you can see because it's calculated some of it, it just shows up immediately. But if I hit calculate, you see now it's keeping track of that point too. Which in itself is making an interesting shape, so it's like making this this triangle. Okay, yeah, it's super fun to watch. It's honestly, it's one of those things that I could just sit here and just watch it all stream, but you know, I know you guys didn't come here to just watch me watch a bunch of pretty lines. But yeah, I need to reconstruct my model a little bit such that I can actually pull a gear in from the Solidworks toolbox, and then on the fly I can actually change the on the fly. I want to be able to change the number of teeth the gear has and just see what it does. So I think I did this in inches. This is power transmission. It's a gear and it's a spur gear. And I think it memorized my settings. I'll make sure here. Yeah, I used a diametral pitch of 24. And let's just take this down to just 100 teeth this time. It's going to be slightly bigger than this one. Face width will be just 1/8 of an inch. Pressure angle is 14.5. So, you know, that, you know, the diametral pitch and pressure angle are things that need to match between sets of gears in order for it to be able to work. So I'll just leave it like that. And I might even remake this, since this is a dumb solid and won't be able to listen to any changes from this gear. So what I'm going to do, I'm just going to suppress this. Yep, sorry to see it go, but you know, these things happen. So now just starting to mate this in place. Okay. So I'm just going to try to get the teeth in there as best as I can. There should be a couple of sketches in the Solidworks Solidworks toolbox part that should be the you know, the actual diametral pitch of the whole thing. So yeah, I might have to open up this thing and read only just to see what kind of sketches it has. Yeah, that's cool. So what is this? Okay, this does not have what I want. So that's for the revolve itself. Okay, I think this is what I want. Yeah, tooth cut, or two cut ske, has the diametral pitch circle right there. So yeah, let's see if we can get this boy to show up. That'd be pretty nice. And actually this one doesn't have it either, but I can actually add it, I believe. If I just go ahead and say this. Oh, hey Vito, also known as Virus. Good to see you, man. Welcome to the stream. We're just we're gonna be playing a little bit more with the spirograph that I had from last time. But I'm making some edits first, just so we can have some real fun with it. Like I wanna actually like play around with a bunch of parameters and hopefully just see it like spit stuff out in real time. Okay, so we have that there. So perhaps I can say this and this be tangent, and that fails likely because yeah, the sketch is in the wrong plane. Oop. So I can't really change the toolbox part, so I'm gonna have to change this. But practically no work is lost. I think I just have to change the sketch to this plane over here. Let's see what that does. So this with this tangent, and then that works. So yeah, you see? And then, yeah, this is gonna be interesting. Yeah, I might have to manually adjust the actual meshing of the teeth, which is fine, but the thing that I want to happen automatically is the length of that basically driver arm that I just set to hide. But yeah, so let me take this spur gear. So let's take the origin, and let's say you will be coincident to the right plane, and I'll go into mates and even rename this. And this is to reset the spur position. Oh, I typed in a plus, but that's okay. So that's something I have to remember to suppress when I try and run the motion study, but you know, just so that it's not wiggling around on me. You know, that, you know, having it stuck in place will help me for this next bit, which is to create a new part. So I will say, let's sketch on the assembly front plane. You know, grab a slot, and I need to be careful how I do this. So I'll put that coincident there, and I'll put this coincident to here. So two external references to basically define the length of this. So why did I do it like that? There's something really subtle I did, and notice is because I didn't really draw it like this. I didn't just draw it straight down and then do this. Difference being, just drawing it straight like that adds a vertical relation. And being that, you know, this thing has to rotate, this vertical, this bad boy, might actually cause us trouble. So I'm trying to just use basically the perfect amount of relations. And then I can just arbitrarily define the radius. It doesn't really matter. It's critically the length and, you know, where the two endpoints are. Alright, so, whoops. Actually, I need to go back to this edit component, because now I need to extrude. And let's see. Looks like my plane was a little bit off, but I think this might be fine. Yeah, because what I can do, and I'll show you. So let's just give it a thickness. This is fine. You know, just leave that as is. I'm going to delete this. Well, not delete. I'll suppress this in place mate. I suppress because if something gets really goofy and I need to stick it back where it used to be, you know, I actually can put it back where it originated. So now I can just say, make that coincident, make this concentric, and this with the extrude to surface and call it a day. I could do that. Reason I don't is sometimes it can get a little bit screwy when you're trying to extrude to surface and things are moving around, because a lot of the times you need to see like enough surface to actually go up to. Although I think in this case, since the up to surface is a planar surface, those are like the most well behaved. I think that's also an acceptable solution for that. Alright, so what we should have here, you know, I made it that coincident, this coincident. If I turn off the reset spur position, I should have this rotating about this. Keep in mind, the spur isn't going anywhere because I'm actually going to use solid body contact to take care of the rolling. But what I'll do is test. If I go right click and say edit toolbox component, and I'll actually make this internal hole smaller. So that's the nominal shaft diameter. Maybe I'll put that all the way down to like a quarter or something. Yeah, it's looking pretty good. Pretty good. But the most important thing is I take the number of teeth, and let's say I set that to 70. Okay, I heard a ding of sadness. So what is failing here? So I think this. So what happens if I just hit rebuild? No, it hates that. Okay, so what did I do? I think I might have created a circular reference. Let's cancel. It's all good. Troubleshooting 101. Can I show... What am I looking for? Hidden tree items. I forget what they're called, but maybe I'll see. But there's actually, you can actually see the external reference. I think they're called pointers. But I think what's happening here is that this gear can't be tangent to the teeth unless this member gets longer. But this member can't get longer until this moves to the teeth. So it's creating a chicken and egg scenario. And in Solidworks, that is called a circular reference, and that's something you want to avoid. Like, even if they don't outright cause errors like this, they can be very brutal to performance, especially. So, you know, we'll figure that out here. Oh, hey, Melectrica, it's good to see you again. Welcome to the stream. You know, we're going to be playing around with the spirograph once I figure out what's wrong with this thing. So, how do I want to do this? So, I know I can, if I suppress this, you know, that allows that to solve. If I hit rebuild, I think what I might have to do, this is underdefined, but yeah, that should be. Let's see what's up with this sketch. What is this sketch up to? Okay, so I think I know how we can fix this here. So I mated this, or not mated, excuse me. Let me be specific here. I put a relation to the endpoint of this line to the part origin. I think if I delete this and instead of grabbing the part origin, which is in blue, grab the assembly origin and say coincident, now that should create a case where it's able to stretch properly and not create circular references. Okay. So let me try edit toolbox and just change the size of this. Okay, so we outright didn't get an error this time. But now this is always going to... The sketch is going to the assembly origin. I might be able to turn this back on and get no errors. Okay, so far so good. So I'll even turn it this way. So if I go edit toolbox component and not diametral pitch, not that, just change the number of teeth here. It might be just something that I have to just turn this off so it rebuilds and on. Yeah, I'm good with that. So there is a circular reference, and there may be a way of circumventing this. And yeah, I know there is, but you know, just wanting to just get on with the program. You know, I find that acceptable. So when I change the number of teeth, it's just gonna throw an error. But I turn this mate off so it can rebuild and just turn it back on so it sticks. So yeah. Let's save. And for our motion study, I might even create a new one. Assembly, new motion study. And we'll start by just driving a motor. 12. And say we want solid body contact between this and this. And then I want to hide this. Hide. So now this should go around once, and you should see the gear turning. So let's see. Well, actually the frame rate is so low, I can't actually tell if it's working. So let's just let it do its thing here, and we'll take a closer look at it once it's finished thinking about it. Oh, I also have it at quarter speed. So let me replace key. Oh, I'm in animation. I'm so dumb. Thank you so much, Alessio. You see, it happens to anyone. This is literally what I was talking about. When I say, like, yeah, it happens to anyone. It's been a long day for me. It's like, why is the frame rate so low? And that appears to be working. Let me make that slower. Oh, if it wants to. Yeah, so now that's working. Thank you, Alessio. You're the man. All right, so that's part of it. And then actually, let's do another test. So what if I go? Also to me every time. Yeah, really, I wish that. Honestly, that's mostly the mode I want to use. I wish there was a way to just set that as a default. So let's change the number of teeth. So 100, it's gonna error. It's okay, but we turn this mate off and then turn it back on. And then go here, the updated position, which is cool. That's fine. And now we should have this. Let's just replace the camera key so we see. Oh no, I have to recalculate. I hit play instead of recalculate. All right, so that is functional. So what I will do now is this next part is going to be interesting because I'm not really allowed to modify this toolbox component. This gear is a toolbox component, and they're read-only. But what I will try is to make the actual spirograph bit. It's a new part. On sketch on the face of this gear and just say convert entities. And this might take a second because there's quite a few teeth. I saved, so I think this will work out just fine. Yeah, this may not be the most computationally effective way, but we'll see. Boy, howdy, that's a lot of on edge, am I right? So let's do that, because I think eventually And what I might even do is have it extrude to the other way. So basically, yeah, we can turn off. No, actually, yeah. Oh yeah, that's cool. That's cool. So flip. So what I can do is hide that toolbox component, and then we basically have a part that will change. That will change with the toolbox component, but will allow us to edit it, and also won't even have to change the number of mates to it. So what I think I can do, so the toolbox component, we can just hide, honestly. And let's just, again, test. Like the key to being successful with animation is frequent testing. It's easier to kind of figure out what's going wrong. It's easier to figure out what's going wrong when it's like one step at a time versus it's just happening all at once. So yeah, you see the entire gear change. So that is completely functional. All right, so I think we're ready to make the spirograph bit, and this shouldn't take so long. How do I want to do this? Questions, I tell you, man. I might make that like an independent thing. So I'm gonna start. So the way I did this on the other one, I started with a small circle, like this, and then I used the helix and spiral command. So it's going to be very important that I don't put any relations to any of this teeth, because if you recall, it's pulling those edges from the gear. So if I put like a coincident to this tooth and then I change the number of teeth, that specific tooth might be gone, and that's going to cause errors in this part. So I'm going to avoid snapping to any of these teeth. Oh, Yashwanth, what's going on, my man? Welcome to the stream. Good to have you here. Playing with a spirograph, and it's going well, I would say. I've hit a couple of roadblocks, but you know, I'm resilient, so I'll figure it out. So with the spiral, I can start with this base circle here and have a spiral just kind of projecting out, and you can kind of play around with different aspects. So I might just go in and manually change this as I change different gear sizes. But yeah, let's do that. Alright, so now we have a spiral. What do we do with it? And how do we get the holes that, you know, you saw in my spirograph? So I'm going to start another sketch. Click on the spiral here. We're going to convert it. So that's step one. That's easy. Step two is something you might not have heard of, and usually I end up searching for this command. And if I plug this, so I can say search commands, and the command I want is called segment. And what segment does is allows you to put in a curve as an argument. You click on a curve basically, and what it does is it just splits it up into an equal number of segments. So I'll show that here. If I click on it, I can say, well, can you equally space 5 points about this curve? And you know, that's absolutely what I want. So just something like that, pretty much. Vito, is there a more efficient way to rasterize a toolbox component? I think what you're getting at is like, is there an efficient way to basically do exactly what I'm doing right now, where basically I'm taking a toolbox component and need to modify it in some specific way. I think if you need to have this, honestly, I think you could save the read-only part into a regular folder and then modify it how you want, but Solidworks flags it as a toolbox part, and that causes some quirky things to happen. I think you could probably do a save as, but yeah, I just chose to go about it this way, I suppose. Yeah, I just know when SolidWorks marks something as a toolbox component, you know, it's just weird. And I have a love-hate relationship with Toolbox. Like, I think it's so cool that you can just pull all sorts of geometry from, you know, just from the window. It's just easy. You don't have to go anywhere for it. But it's also like very hands-off. Like, you're not allowed to modify it other than that like menu that I was going through. So, you know, it's a double-edged sword. Hole wizard. So I'll get some holes here. And for positions, I'll sketch on this plane. Oop. And just kind of snap these. I think that might be too close. And what I'll do is make these holes smaller. Okay, and that's a spirograph in essence, pretty much. So I can hide this. Well, actually, no, I do want to keep that around, but I want to hide the spiral. Keep sketch 3 around because I can actually pick those points when I do trace path. So let's go back to our assembly, and we're practically, you know, on the cusp of just having everything we need. So going to our new motion study. Gonna have to recalculate. So that is rolling. That's cool. You have to delete all reference for the toolbox and create it. Yeah, otherwise you screw up your toolbox. Yeah, Alessio has it right. I kind of just stay away from it. And you know what is interesting to note is that if you go into your system files, if you're brave enough to do that, here I'll show you something, if I can find it. I won't go too much out of my way. But for example, if you go into your program files and say, you know, SolidWorks Corp, SolidWorks, there is an exe here. Yeah, this one, SLD Toolbox Configure.exe. So this is found in C program file SolidWorks Corp of your year, SolidWorks, and then this thing. So what this tool is, oh, actually no, that's not what I want. You can create new toolbox component. It's this one, Toolbox Updater. So what you would, is it this one? There is a exe here that you can feed it a toolbox component that you copy, and you basically say, I want SolidWorks to mark this as not a toolbox component, and then it just becomes like a regular part. That's something I would have to look up. I used to know it a little better when I was in tech support, but that is like a tool that exists. Schaefer, what's going on, bro? Good morning. Yeah, good morning to you as well, my man. Welcome to the stream. You're on the cusp of seeing something very cool here. So, you know, let me hide this. And now let's get our paths. So, unfortunately, I have to do this kind of one at a time. Let me boot that selection out. Trace path. This. Ooh, now we're getting somewhere. So, okay. I'm gonna have to put another one. And that's why I didn't want to go crazy with the amount of points I put here. This, and that. Trace path. There we go. You know, and I'll let it run a little bit longer so we can actually see some of the cool patterns it creates. Like the other one, I had to let it run for like a minute and a half to actually complete the entire cycle. And then in video editing, I just kind of I just sped it up to make it a little bit more watchable on social media, you know. And looks like we got one more, at least for the version of this that I have. Motion study. Oop, just kidding. This. Trace. Alright, so there's our paths. So let's let me get this in place. Replace key. And let's bring this out to 30 seconds. And let it calculate. This is really, really cool. Yeah, so this is like very similar to that sunflower pattern I was getting. But yeah, you can control how many points this has by varying the gear ratio, basically. So something I can do, so I know the ring gear has 300 teeth. Oop. No, I meant to go click back into model. So if I go here to the toolbox, edit, and set the number of teeth to 100, which is divisible by 300, gives you 3. Off, on. You know, let's see what that does to our shape. Yep, so just as I expected, because it's evenly divisible by 3, this spiral graph gives you 3. This spiral graph gives you 3 points, pretty much. So it's like a triangle. So what else can we do with this? Let's go open this up. Let's play around with the spiral here. So what happens if I let's bring the pitch down to 2, maybe the revs up to 0.5, I meant. Maybe a little more than that. Okay, so let's try something like that. So you see you get something like that. Because I use the segment command automatically updates. So we should be able to just go back into our spiral graph and just run this. Yeah. So that now they're a lot more spread out. All right, what else? What else? So let's go back in here and say oops, that's not what I wanted. Let's change the number of teeth again. So I bet we can get, you know, if we, instead of like having 100, if we have like 99, like ever so slightly off. Yeah, let's give it a second to error out and we'll fix it right away. So now we should get a thing with like a lot of lobes. So it should be like, yeah, slightly off. This one's turning out to be cool. Wow, those lines are they're getting kind of dense, huh? Yeah, and I could even let that keep going. I might even, you know, instead of having this have so many lines, just like hide all of these plots. And let's see. Yeah, now that I think about it, there's not that much more to change, because if you consider any particular any particular like point. It's like it's a distance from the center here. Yeah, so even like this spiral, like of course having it in a spiral formation will kind of make it look like a ribbon, which I think is pretty cool. But for any particular path, it's really only like the distance from the center and the number of teeth, but I could be wrong about that. But I'll try a couple other values. I have a feeling about 57, like Heinz ketchup. Avito saying these slight offset spirographs definitely look cooler. Yeah, I totally think so. And I think it's really because... oh, that's really interesting. A couple holes failed. Oops, I did the wrong thing. So that... Yeah, and I think because like they're so close that it makes like this very nice ribbony thing. So what I think is going to be interesting here is that the point we're tracing is actually outside of the gear, which makes the hole fail, but it's not against the rules in terms of tracing a path. Let's see. Oh yeah, this is what I'm talking about. Oh boy. This one's really cool. Yeah, and because 57 is just not very evenly divisible, this would keep going for a very long time until it actually meets back up with itself. Yeah, I'll try something a little less like stunted like that. And maybe I'll try with a point just like way out there. So let's, not diametral pitch. Yeah, in my post I actually had 96. So it actually makes 25 lobes. So like the sunflower shape has 25 petals in it basically. So I might do like one or two more and then I'll actually get onto the CAD model today because I've been streaming for an hour now, but I tell you, like this stuff is like so fun to play around with. Yeah, that's so cool. Yeah, it's basically making like a flower. So put this here. Actually, let me go in here and say, yeah, with the helix, let's just bring this sucker like way out. Yeah, actually the holes are okay with it, which is weird. I would expect this to error out, but okay. So the point we're keeping track of, I believe, is this one. So this is going to be interesting. Whoa. Okay, I'm gonna have to zoom out a bit. Hang on. Yeah, I think I'll make this one my last one, but... yeah, this thing is so cool. Oh, it's like making a donut. That's so cool. Oh god, that's so satisfying. That is so cool. What do you think about that, guys? I really like this one. I also like donuts, so yeah, I think that's a good one to just kind of like leave it off at, as then I'll go to the actual CAD model today right now, but let me know if you enjoyed that, cause I sure did. Yeah, I really enjoyed that. Yeah, let me take a screen snap. Yeah, I honestly didn't expect it to be this beautiful, but you know, math is beautiful, man. It's like a shame that, you know, a lot of schools just like beat the amazingness out of like mathematics and science because it's like of a bad teacher, or like a curriculum that is not like accepting or inviting. You know, that's why it's important to just like, that's why I'm doing this here. You know, this stuff is fun, and you know, having, of course, you know, free access to my videos is one thing, but just to you know, just to have it be fun, you know. Oh, sick. Avito, you said you got the email regarding my new Solidworks user group opening. That's awesome, my dude. That, oh man, that's you're gonna have so much fun. I'm telling you. Especially, I don't know what your plans are gonna be after the pandemic is over and we can like visit each other freely again. But yeah, you know, once you get like people visiting in person and just like showing off the coolest things in person demonstrations and interviews and stuff like that, so it's a very fun place to be in. And I know I've talked at length about that. All right, so save this. Let's just save all. And it was also pretty cool that, you know, I made like a SolidWorks assembly that, you know, kind of reconfigures itself based on Toolbox components. Of course, it's not perfect. Like, you know, I had to like keep turning on and off that one concentric mate in order for it to like actually, for it to update properly without any errors. But yeah. So what I think I want to do for today's CAD model of the day. Yeah, let's see. Let me put this back here. Yeah, I'm thinking of making one of these for today. I'm sure you've seen one of these before. It was like a soda can crusher. So I think it just has a couple of basic sheet metal parts to it. Let me see. Does it have... Oh, this one's even got... Wait. Instead of foolproof, it's full-proof. Like usually you would describe something as F-O-O-L, foolproof, like even a fool can use it. But instead they put foolproof, which is kind of funny. Okay. Alright, so this is helpful. So, yeah, this is a crank slider mechanism, it would seem. That pivot looks fixed. Is it possible for me to view the image? Yeah, I think I'll use this as my my reference image. This one's very nice. Just to have it in its various stages of operation. So I think what I would have to start with, and I might have to just make up some dimensions here. Yeah, this is totally doable. And let me move this to my my other screen. Put that over there. And put this over here. Vito, imagine I imagine coding a macro to increment the number of teeth, enable that slight mate error, and you could have it render a couple of patterns to actually show off the effect of extra teeth. You know, actually getting into macro writing is something on my bucket list. I've never done it before, but I think that's something that could just be massively, massively helpful. And I've just seen the amazing things people can do with macros. It's just one of those things I keep putting off, man. Alright, so I'm just gonna start with like the sheet metal base. So it looks like almost like plate. It's very thick. So I'm just gonna call this 4 inches. Wait, does this? What, I think I recall this having overall. Yeah, it does have overall dimension. That's sick. All right, that'll help a lot. So it looks like the usable can area is 7 inches, but this thing's supposed to be a bit taller, so I'm gonna call this 9. Oh, by the way, do you hear this song right now? This is what I use during the spirograph video. This is Menma by Cordio. Oh, by the way, I keep neglecting to mention this, but all the music you hear in my stream, basically all of it, is made by Cordio, a good friend of mine who gave me special permission to use his music, and for that I am super thankful. So shout outs to Cordio. If you want to check out his music, it's in the link in the description. You know, that'll take you to his Bandcamp if you want to pick up some of his music. But it's awesome for, like, you know, this kind of thing where it's just like very focused. So you're no audio. So you're not hearing any music. How about now? So I just basically doubled the volume. So hopefully that works out a little better, although it's a little loud to me. But I can do this, so now I can hear my own voice, so that might work out for us here. Yeah, so, you know, I really appreciate the feedback here because, like, you know, I'm okay with Solidworks. My expertise is in Solidworks, not streaming, so, you know, I appreciate your guys' patience as I work through my streaming issues here and there, and, you know, giving me suggestions. All right, perfect. We nailed it. Awesome. And what was your previous comment too? Maybe technically scaling the background image. So scaling the background to the can size. Oh, I could do that. Yeah, too. But what I might even do, honestly. Yeah, because like I want people in the stream to just kind of know what I'm going for. How do I want to do this? Yeah, there's not too much space on my stream, unfortunately. Here, I'll try this out. Let me get my snipping tool. All right, so that's the donut that we created. I'll just leave that there. That's fine. Yeah, so the reason I don't want to use this as like a sketch template is like it's like not like 507 mechanical movements where it's just like where it's just like, you know, the black and white. Like this is like full color, so these kinds of things are kind of tough to sketch over. So, you know, we're making the back portion. And I think I'll just throw that to sheet metal. So let's use the gauge table. Whoops. Oh, so I have to still select the table. All right, steel. So now we should have another field come up. Let's try 10 gauge. Okay, so that's pretty decent thickness. I'm cool with that. Alright, so now we have the tabs that come out that actually capture the slider in there. So I'll accomplish that with edge flange. Like this, and let's have the bend towards the outside like that. And let me think here. Yeah, in the picture, I'm just gonna pull this here. So I'm modeling this flange here, this one. It goes all the way down, but then I believe it stops to actually make room for whatever this thing is that I'm tracing. right now. So I can do that by editing the flange profile, taking this and just kind of ripping it out of there. Now I can define it. Like that. Sketch is valid. Yeah, and I believe we can mirror this, so I won't bother doing it to the other side until I get this a little bit closer to what I want it to be. There we go. Yeah, so I think one of the pieces of equipment I need to get for my stream is a mixer. And I've actually had this where I stream to my friends like over Discord or something. It's like the audio for the thing I'm doing will be like of a normal level, but it'll be way too loud for me, and that's what's happening here. But you know, just putting the headphones like sillily on my face actually works pretty well. So you know, I'll just leave it at that. Have the bend towards the outside. And actually. So this ends a little bit, so I need to go back and edit. Although, you know, I don't need to have it be exact, you know. I can take some liberties. The important thing is I need something here to actually catch the slider. So I can do that. We have something like that, and I actually may go for the mirror now. So mirroring about the right plane. We also want edge flange 1, and let's give this a save. 495 soda can crusher. Alright, and now to make this bottom portion here, I may just make it a solid and then just shell it, because this is clearly formed. This is not just regular bent sheet metal. And it looks to be formed, so how can I do that shape? I will draw its profile as seen from the right plane. Let me adjust my mouse to Solidworks mode. Like that. And I'm just going to give this some random dimensions. Oh, hey Kuronai, good to see you. We are making a soda can crusher. Yeah, so I'm starting with the base here, moving on to this bit. Then next is going to be the slider, and then after that we're home free in terms of like, you know, the more complicated parts to model, because after that it's just linkages and the handle itself. So you know, this was a quick one, but I spent, you know, a large portion of the stream playing around with the spiral graph. So, you know, I needed to balance it out, you know, so, you know, in order to have more time to play around with that, you know, we have a simpler thing to go on. But yeah, it's pretty good. Pretty good. For uncheck merge. And all right, how do I want to do this? Let me sketch here because I do want to make the end rounded. Let's get a 3-point arc like that. So if I can grab the midpoint of this and say coincident, that should put that fully in place. Then I should be able to go to extrude cut and say through all and destroy all the material on this side. There we go. We get something like that. Save. And now let's get some fillets. I'll start with these, which will be on the larger side. And then this, which will be on the not so larger side. And that's pretty much it. So what I'll do is I'll shell. Yeah, perfect. Well, I might go back here and just hit those. Yeah, I'll just leave it like that for right now. You know, those corners are a little bit on the large side, but there's our platform, and I can actually keep this all on the same part. So next thing I want to do here is the slidey bit, and I need a moment to study the picture a little bit. Let's see, so we have what appears to be just like a sheet metal U-shape pretty much, but it's got a notch cut into it that mates up with that very short flange that we modeled earlier. Yeah. Oh yeah, shell's pretty convenient. Yeah, for sure. You know, especially if you know how to set it up. You know, I could actually make an entire YouTube video on like, you know, doing quirky stuff with the shell command. Lots of things with it. So how I think I want to do this, I want to make, here, let me get my, where's my snipping tool? Aha. I want to draw the U shape, extrude that out, basically. This is cut at the bend, so I would flatten it, cut the notch out of it, and I can actually cut this shape as well, and then fold it back up. I think that's what I'm going to do here. How to shell a sphere. I can show you that real quick. It's not as bad as it sounds. Yeah, but first we need to make a sphere. Yeah, just give that a value. I don't really care what it is. And there's our sphere, and all you gotta do, shell. It may be kind of confusing because, you know, what do you pick for the faces of the sphere? All you gotta do, you just hit check. And if I open up the sphere with a shell, indeed, the shell actually worked. So what trips people up a lot, and this is why I was saying I could make an entire YouTube video of me doing quirky stuff. You don't actually have to put any arguments in this box. You don't have to put any faces here. You could just leave it empty, which is like, you know, I think it's one of the only features that do that, because with practically every other feature in SolidWorks, like, you know, you can't apply a fillet and then not pick an edge, right? Just leave this box empty, but that's what you do here. You just leave the box empty. And if there's multiple bodies, so for example, if I put that back there and then say move copy bodies, say copy, and then do that. Okay, that looks a little sus, but whatever. And then I run shell again. You see what happens, it intuits that there's more than one sphere. And what you do is you pick the one that you want. So if I do that one, shell, only one is, but not the other. But if I bring back the original, oh, I guess that fails. Oh yeah, because now this gains a body argument. So I guess when you have multiple bodies, you do have to tell it what body you're talking about. there you go. We got some bowls or balls. All right. Any rate, yeah. So that's the short on that. The little quickie on that. Oh, thanks, Gurren. I think it's like, and that's just scratching the surface, really. Because Shell is like being it's like so close to being like an official like surfacing feature. It's very quirky in that regard. But yeah, what was I about to do again? Yeah, this thing. All right, so I think I'll draw it bottomed out first. Yeah, so I'll sketch here. Amazing. Oh, I'm glad that that helped you out, man. It's the thing that a lot of like, self-taught, there's a lot of SolidWorks content online, but it's just like SolidWorks is it's just so incredibly deep into like what you can accomplish with it. It's like it's very hard to know absolutely everything. Like there's like videos like learn SolidWorks in 5 minutes, and it's not a bad video. The guy shows you like how to open up a part file, what a feature is, yada yada yada. But to reach like expert or like CAD master levels of proficiency, it just you gotta be putting yourself in these situations, which Vito, you're really good at. You think of great exercises. Actually, you suggest good video topics. I guess is what I'm saying. But yeah, I can make the height of this. I'm just gonna call this 2. Cranky Kong says get good. No, but no, it ain't like that. I promise. Okay, detour. Cranky Kong says get good. Yeah, I should just leave. I should just leave the video like this. The stream is just 1 hour of this image, just showing up. SolidWorks is like raw ingredients. You could eat an apple and be happy, or make a full-blown meal. I think that's a very apt comparison. That's a very good comparison. I think it really is like cooking. It's like you get better by practicing. You can learn by observing other people doing it. You can learn recipes, so and so. Like there's videos, and I have a couple of them. It's just like, here's how to model a peep, And it's not, and I try and sprinkle good information, but it's like following a recipe. It's like, if you want to get really good at cooking, you could just follow a bunch of recipes and build like a library in your mind. But when you start digging into it, saying like, oh, if the cut of meat you're cooking is fatty, then you should do this to it. And this is where the analogy will start falling apart. Because like, I'm not good at cooking at all, but it can be that deep, Yeah, good old, yeah, and I sent you a peep hair clip, didn't I? I should bring those back, honestly. I really enjoy making those. Okay, so we need, what do we need? To reverse the direction of the thickness. That's what we need. Excuse me. And how far does this go out? Good. So yeah, this covers the entire surface, which actually makes sense. So I'll just bring this all the way out. Let's just do a 3.5. Yeah, and that's all we need. Make sure, yeah, there's no merge result here, so we can proceed. Oh yeah, and I have the display where all the tangent edges are hiding, which is not helpful for this. So view display. I like tangent edges as phantom. So you can actually see where the bends are in this. Music sounds like it's having a... Yeah, there's a couple of songs in here where he like goes ham with the oscillator. Okay, so something that bothers me, you know, and this is like such like a first world problem. So yeah, no, it was the track itself. Guru Night. Yeah, it was just like the what that was. But what bothers me is you notice that my icon colors are different. They're legacy. So, you know, if you install a fresh seed of Solidworks, you know, it will give you the choice between the light colored icons like this, which I don't like, for the reason that, I don't know, it's harder for me to spot the icons because everything is just like light blue on gray on slightly darker gray. It's just not very noticeable to me. So I changed the whole thing to medium light, change it to classic icon colors because I like the green and yellow. But if you look at sheet metal, tab and slot does not have a classic variant on it. It's the 2016. It's the 2016 one. So it's just like, it's just way out of it just looks weird by itself. But you know, I love you, tab and slot. You know, that's another thing I can make a video on, although I haven't used that as much. What was I doing? Oh yeah, I need to cut a notch in this, and to help me do this, I will unfold. So the fixed face is this, and then I'll say collect all bends, which will grab both of these bends, and we'll lay the sheet metal part flat. And now in this way, I can sketch on this face. Do I want to make this a precise fit? These are questions, aren't they? Yeah, I guess I will. Just in case it might make mating it a little bit easier. But in reality, there would be a little bit of slop in there. Oh yeah, you like the unbend? Yeah, no, that's another like under appreciated feature. Are you already been here for 10 minutes, already learning new stuff? That's perfect. That's what I'm going for here. That's when I try and select CAD models of the day to do on stream. Like, if I think of like an idea, like maybe the day before, I'm like, oh, actually, but that's like where I can show off this feature. I'll actually save it and then just try and think of something else for a non-stream day. But yeah, this is cool because what you can do is, you know, you can start applying features. So I can say extrude cut, link to thickness, make sure the feature scope is only set to this, so it's not cutting anything else. And yeah, it looks bad now, but it'll fix itself once I fold it back up. Additionally, I might be... Oh, here, I bet what I'm about to show you right now, I bet at least 80% of you don't know about what I'm gonna do right now. So here's something. Draw a line. So what I'm doing here with this one line is I'm trying to emulate this. You see how this is like a slant? So basically this is folded flat, so I need to lop off like this little piece here. So yeah, I want to cut this thing off, but you know, some of you may know that this might not be enough. Well, first, it's underdefined, so let me fix that. So I just need to define this. There we go, now it's fully defined. But this isn't enough information for the extrude cut to cut this, it's just one line. And, you know, those of you who may know says, oh, I'll go get the line tool and start, you know, picking all the lines and make it into a closed shape. And while in this case, you can certainly do that, but what if you have more? What if it's like full of contours and stuff like that? that you need to select. So here's what you do. You have the one line. You might have to search for this one. And what you want to search for is, let me remember, close sketch. C-L-O-S-E, close sketch. And let's see where this is. It's under tools, sketch tools, close sketch to model. So this is, a hidden secret of Solidworks. So if I click that, so what you get is close sketch with model edges. So look at where this yellow arrow is going. It's very light, but it's pointing to the left right now. Basically, it's trying to say, okay, you want to close this with the model edges. Should I go this way to complete the loop? Or should I go the other way to complete the loop? So I want it to go to the left, so it's going the correct way. So all I got to do is hit yes. And there, it just selects all the edges and closes up the sketch. Isn't that so cool? Basically, most people I show that to have not heard of that, and you like to see it. Just cool stuff, because you guys are worth it, with spending your time here, and with all the crazy amount of subscribers I've gotten over the past couple of weeks. I literally can't thank you enough. So it's just like, if I can show you something cool, it's repaying just like, that much of my debt to you guys. Make sure we get this. Actually knew that. Oh, I'm actually very impressed. I'm very impressed. Like, I feel like that's a rare one. Well, that's good. That's good. maybe, yeah. It could have been. Alright, so now we have this cut the way we want, so we just go back to sheet metal, fold, bends to fold, collect all bends, and there we go. It's perfectly fit in there. So we don't have to, I don't have to make all these sorts of sketches, and I just design it when it's flat and then just bend it back up, and it's all good. Deval's saying, wow, that's a really interesting one. Well, good to hear it, man. Or if you want to suggest features for me to play around with, like Ray did the other time, Ray Folks, he's like, what does make independent do? And then I went on like a 15-minute tangent only about that. Here's another cool one. And this is a sheet metal specific one. I want to break these corners, right? Like basically put fillets on all these little corners here. So can you do that with the Fillet Tool? And the answer is yes, of course. But they're kind of a pain in the butt to select, as you see here. So wouldn't it be nice if I could just click the face instead? Click the face and it just finds all the corners for me. Currently, you can't do that in Fillet because, what it tries to do, and I'm going to have to set it small to demonstrate, instead of finding and breaking those corners, it just tries to put a small fillet, right at the edge of that face. So remember, I clicked this and this is what it gave me, which is not what I want. I want to actually round this off. So if I go to sheet metal, corners, break corner, you can set it to fillet, set the size. I'm going to pick the same face and look what it does. It actually finds the edges and breaks them. So I can just click the faces and, I'm not stuck trying to handle these tiny little edges. So that makes that super trivial. Man, it's a lot of granularity in that spin box. Yeah, and that's what that looks like. Sebastian asking, what is the difference between lofted boss and base and boundary boss and base? I'm actually going to take a rain check on that question because that is such a deep rabbit hole that Yeah, and this stream is like already on the longer side. I might have to answer that question next stream. Like I don't like that. I don't like to do that, but it is really that deep of a question. Just know this. I will say one thing. If you can get the geometry that you want with a loft, then just use that one. In a lot of cases, boundary and loft do the exact same thing. I don't want to say exact, but gives like practically the same geometry. And if you get something that you like with loft, cool. You leave it like that. But yeah, but no, it's a great question. It's too great, actually. It's too powerful of a question for right now. Oh, glad you understand, dude. No, I want to do that justice. All right, so we have the slidey bit in there just fine. It fits basically perfectly. So now, what's next? It's not much. We have a linkage coming down here a certain less. Fine then, keep your secrets. Yep, that's me. That's too funny. Yep. Yeah, so I'm gonna model that. Well, actually, I might model that in a separate part because I do want to be able to control the length of this and the handle too. So yeah, I think it's time to start making the assembly. So one thing that I'll do here is say save bodies, and I actually only need to save one. I need to save just this one in its own part file because these two I'm gonna keep fixed pretty much. So we want to consume. Yeah, no, that's a fine name. Yeah, whenever you use this, especially if you work in like an actual environment, you should actually rename these. You know. Yeah, let's create the assembly. Why not? And crusher ASM. Okay, so it'll save that out and put that in its own assembly. So if I grab the new assembly here, why does it always put me on appearances? That's annoying. So insert the base. So basically reuniting them. But now I can say float. Yeah, and now how do I want to do this? I'll make right plane of this with the right plane of that coincident. And why? Oh, I goofed it. I totally goofed it. Fix. Float. That should be right. There we go. So now that should be... I might have to re-add that. It's all good. Yeah, because I goofed it. Why? Oh, I did the same thing. I need this right plane with this right plane. There we go. So, yeah, this can just slide along this. So now this should be free. Like that. Let's take a look at our picture again. So if from here to here is 4 inches, then this thing looks like 5 or 6 inches long. So I'm just gonna try 5. And actually I have to punch the holes in the base and in this part. So actually let me punch the holes in first. Oops, that's the wrong thing. Let me go into the part. I'm not sure how I want to do this one. My 2 center lines say make equal. Oops. All 3 of these are equal, so that should give that a specific location that's kind of central-ish to that region. 2.5. Let's just do that. And ideally, you know, I should have this on the right plane, so I can switch that. And we'll take that, extrude cut. Okay, so that's that. And then, did I goof this up by making this round? Hang on. I think I did. Oop. No, really. This, the first flange needs to go all the way down. Modeling the actually I've modeled rivets previously, and a lot of times if I'm running like low on time, sometimes I'll ignore them, to be honest, but yeah, I'll show you how I do that. Yeah, let me roll this back to the first edge flange. Yeah, and honestly, set this to 0. This needs to go all the way down. And then this, edit. Like this. Oh my god, I almost put that exactly 1 inch. And then hopefully let's roll down and pray for the best. Okay, Boss Extrude is a little angry. What are you angry about, my dude? Someone steal your sweet roll. Oh no, it's not the sketch? Hang on. Oh yeah, it is. Why are these black? Alright, well, let's fix these. No problem, my dude. I'll just snap you. Say, make pierce. I might even just put a dimension of 1 on this. When would it be better to have holes symmetrical to a plane, just making one through all hole? Okay, so that's another great question. So, because previously I drew the hole on the one plane, and then I was like, nah, let me actually just do it on the right plane, and then just say through all, So typically, if you can actually have it on like a mid plane and say through all, that will always be more robust than, you know, just putting it on a face. So what I did there was to what's called reduce the dependencies of the sketch. And let me go back and we'll check it out. Let's go back to the sketch, and I think I can just put it out here with no consequence. Let's see. Yeah, so no consequence, right? But here, something I'll show you. If you right click the corner of the tree, dynamic reference visualization, you can see who's the parent and who's the child. So I can, if I hover over sketch 1, you see that its parent is the stock part that I saved out. And the stock part can change. Like maybe I'll have maybe one of the changes in the future is that instead of these bends being at 90 degrees, I have it at 85 degrees for some reason. And for that, you know, having it on that plane, you know, kind of, it can mess things up if the design is not completely consistent. So, you know, it's depending on something that can change. Whereas if I take sketch 1, edit that sketch plane, and put it on the right plane instead, you'll see that sketch 1 changed its dependency. Well, the thing is like no appreciable, because it's like I put the edges of these lines to the edges of these, right? So there's still some dependencies there, but at least with like the direction of the holes, like, you know, the right plane will always be there and it's unmovable, undeletable. So I like to make things depend more often on the elementary planes than on other pieces of geometry that can move around. Design with intent, exactly. You know, that's exactly the point here. You know, the intent is that I always want these holes to be straight, because if these holes are like at an angle, you know, let's say because you know, the angle of this flange might change, then, you know, the mechanism will bind and it won't work. So the intent is I always want these holes to be coming straight out. So, you know, that's a great example of design intent. It's a great question. And you know, that's what I love when, you know, people, you know, tell me to pause a little, because it's like these are the things that I think about without yeah, these are things that I think about without really these are things I do without thinking about. That's what I meant to say. Guys, that was tough. Yeah, going back here. Let's see. Oops, yeah, I'm gonna have to fix them. So I'm kind of doing like the same technique I did with the other one. Oops, where? Say make all of those equal, make that vertical, and that gives us kind of like a central location. Second nature, yeah, and it'll be second nature to you too soon. It's one of those things, like, you know, I try my best to like point out what I'm doing, because that's what a lot of, like, you know, definitely when I was learning, like back in college all those years ago, it's like I was highly dependent on YouTube stuff, and you know, I was just struggling with a lot of it, because, like, you know, it's like going back to the cooking analogy. It's like it was a whole bunch of recipes on YouTube, but no theory as to why those things go together. Like, why does cookies taste good with milk? Like, you know, anyone could say just dip the cookie in the milk, but why does that work? Right? And, you know, I actually don't really know the answer. I just do, but, you know, that's the answer I wanted. It's like, why does this work? And there was really no answers for that. So when I started my channel, you know, I wanted to be something different. I think I made this a quarter on the other one, didn't I? Yeah, so we'll leave that there. Let's go here. So yeah, now we have the two holes. Yeah, so we can make one of the bars right now, and that'll be very simple. And I'll even just make a new part for it. A center point straight slot. Yeah, I'm just gonna make this 5 inches. And then I have some holes here. Got a multi-contour sketch going on. And then bump up the thickness. And there, that's it. Short link. Let's go back here, insert components. Short link. Oh, Vito asking a great question. In the industry setting, do you guys use extrude cut holes, or is it strictly hole wizard stuff to have a properly dimensioned hole in the drawing? Great question. I would say it's highly variable, but I think if like the placement and tolerancing of holes is important, which it is for most cases, you know, I'm just like dorking around with a mechanism, but Hole Wizard just has so much extra information when it comes to tolerancing, so especially getting that information in the drawing. You can often configure the Hole Wizard stuff to oh, that is peculiar. I'm gonna have a jog in this. So yeah, I would say, like, if you're not sure, see if Hole Wizard has it available for you. I just did, you know, circle holes because I'm being a little lazy, but it's all good. But yeah. Yeah, I hope that makes sense. Alright, so I'm gonna walk back on what I said. Well, not the thing I just said, but using a boss extrude. I'm not gonna use that anymore. Instead, I will use sheet metal. just have it the way we had it. Okay, so this might have seemed kind of silly. So I deleted a boss extrude and instead put a base flange, and it's basically exactly the same thing. So why did I do this? And it's because of this next part. I'm gonna use a sheet metal feature, and to use a sheet metal feature, you need a sheet metal part. A boss extrude is not a sheet metal part until you see, like, you know, the sheet metal folder and the flat pattern, you really won't have access to any of these. And the thing that I want is jog, but before I click that, I actually need to draw where my jog will be. Wrong face. Sorry guys. This face. And I'll have a jog going right through the middle, just like this. So jog. So what this does is, well, that. You know, I'm gonna have this thing bend around the geometry so it actually kind of fits. So center bend. Is there any other option for this? Girl night. By the way, cookies go well with milk because milk mellows out the sweetness from the cookie. Cookies have a chemical called methylbutanol, which is the toasty flavor in milk, and milk and hot tea releases it more. See? Yeah, that's... I didn't know that, but I'm glad I do now, because like that's like the level of knowledge that I'm looking for. Like, I don't want anyone to tell me just put cookies in milk because it tastes good. I want to know when I put a milk... why am I trying to put milk in cookies? That doesn't make any sense. When I put cookies in milk, why does that taste good? And that's the explanation that would satisfy me. You know, so that's very good. Thanks for that, by the way. But yeah, we have a jog here. Should I have it more extreme? Yeah, that's looking pretty good. It's uneven, but you know, that doesn't really matter to me. And I actually should have measured how much that goes. Overall dimension. Yeah, I piqued your interest. That's what I aim to do on this show. Questioning everything. Yep, Sebastian, that is how an engineer thinks. Alright, so did we lose a mate? Yeah, that's cool, but no biggie. I might even just say edge to edge, which is typically not the best thing, but gets the job done. So yeah, now this, I might still have to put the jog way back, because if this thing needs to come down here, this needs to be back there, but this is easy to do. You just go to the sketch, take away the two, that's two of them, and now I can just scoot this back. And even, let's see, give a dimension like that. 7.5. So now this will bring the jog way back. More anger. And I notice a jog went the other way. Oh, yeah, so... Okay. You see Mr. Black Dot here? He tells you what the fixed face is. So which face do you bend up and which face stays where it is? So this black dot doesn't move, so to fix this, I gotta move this black dot to the other side of the ring. There we go, fixed. Is there a way to tell Solidworks to solve for a value, e.g. the jog, by placing it in place and mating the coincident surface? I don't think you can do it with the jog tool. I think you can do it with surfaces, like have like a sketch of this thing, you know, as seen in profile, you know, have like a top-down assembly where you're actually defining the sketch with relation to the part. thicken that, and then if you want, you could even convert using convert to sheet metal if you need to see a flat pattern. But what I really like about the jog tool in particular, and why I'm okay with like kind of doing the trial and error thing, is it's mostly this thing, fixed projected length. So it calculates how much longer this thing has to be in order to actually make the two holes rest exactly where they are. So this is great because that means I can adjust this jog however I want. Those holes will always be 5 inches apart, which is awesome. If I don't, you know, you can see because I'm bending it in this way, you know, this flange is getting a bit shorter. But yeah, fixed projected length is, you see, you guys are asking the best questions here. Yeah, that's why I'm using that. And there, that seems to be much more functional. So it doesn't go all the way down, but it doesn't need to, because you're not gonna squash a can perfectly flat, right? So I think that's gonna be acceptable. All right, so I need to get the handle now. So we're almost done with this thing. And yeah, so it looks like it's on the outside of this going here. Yeah, I guess I should make the jog actually go in here, because the thickness will make this line up and I'll just be able to have a straight linkage. All right, no surface development stuff. Yeah, I guess not today. Maybe the thing is, like, you know, for the entire month of March, like I really am trying to do like this mechanism challenge, and by nature of it, like most of them are just like blocky and prismatic. I'll think of something, because like I can also knock out what's the difference between boundary and loft with surface development things. Yeah, so that's something I gotta think about. So 150 thou is the value. So let me go back here, hopefully for the last time. Interesting. Oh, I guess because there's no flat, because it's just two bends touching each other, that's why it gave me that. Alright, so yeah, now that kind of perfectly fits into there, and this should be basically coplanar. Or be 5 thou off. I'm not really sure what that is, but okay. But you know, something we can deal with. Not too big of a deal. Oh, I whooshed it. Yeah. I'll do that sometimes. Alright, so let's take a... So these are pretty...
I was wondering, have you seen...
Yeah, honestly, if this was a production thing, I would actually fix that.
What kind of movies do you
And I might try and... I have an idea of where that might be coming from. So these are like 3 inches of, you know, I'm just gonna guess. And then you have an arbitrarily length handle. So if I go back into here, I'll investigate for... this actually. Just put it to this. Oh, I did this a blind value, didn't I? I should have done up to surface for this. Just like a veto would suggest. So I'm just gonna do up to surface, so that's why that was being weird. Yeah, from the bend edge, because the thing is, like, the design value is like 4, but you have to add the thickness of the sheet metal, which is, you know, not always perfect. Alright, so things do seem to be functional here. Let me hit rebuild. Make Or I guess it might come from the jog. Hold on. I mean, if I say from here to here, so a clue. Oh no, because that's. Oh yeah, that's what it's from. Because that's like a nice round value. Yeah, so what's happening is this is like has like a weird decimal for the thickness of the sheet metal. I'm pretty sure that's what it is. You know, I could keep investigating, but you know, the stream's got to end sometime, you know. But let's move on to the handle. You know, I'll still be able to make it work. It'll be fine. And plus 5 thou, like that's something that you can actually bend, bend in the sheet metal. And sheet metal is very interesting as like a whole like concept. So I think I'm just gonna start with a handle. Maybe have a 1-inch handle going across mid-plane 4 like that. So we have like a bend downward and then it comes out at an angle, which I can deal with. I think that'll work out nicely. So I'll start here. And let me try something. So it comes down. Do I want to put the curve in now? Sure, I'll do that. So I'll give that like a value. Oh, good point, Joseph. I actually do go over that a little. Yeah, I actually do go over that, and I think it's mostly analogous to the solid body variants because I go over lofted and boundary surface, but there's also a lofted and boundary base. A lot of those will be the same thing. Yeah, and I think I even have it time-stamped too, so you know, if you're really curious. Yeah, thanks for the catch, Joseph. This is the perfect situation to have a value solver, so I could say I want. Yeah, yeah, that's true. That's something I'll look into. But you know, for right now, you know, one of the important things, like, and I think past me would have stopped at nothing until that little like 5 thou discrepancy is resolved. But what CAD Model Today told me to do, you know, of like 494 so far successful posts of posting on time, like I have not missed a single day, is that yeah, sometimes, yeah, you don't have to be perfect. And that's hard for me to admit because like it's just like I am such a perfectionist when it comes to this stuff. And you just got to cut it off somewhere. Like here. What does that mean? Yeah, this. So it's a video. I didn't. Oh my god! I didn't even know this was a video, dude. I just saw this clip, this still. Some garbage is okay, but yeah, CAD Model Today, you know, one of its core principles is this: like, sometimes you just gotta get it out. Some garbage is okay. Yeah, and obviously it's like, you know, take that with a grain of salt when you apply that at work, because like, you know, the reason I'm so lax is because, you know, I'm just studying a mechanism right now. If I was sending this to production, you gotta figure it out, dude, or you know, or else something could be scraping or something like that. Yeah. I want the overall length of this thing, so I need the virtual sharp between these two lines, not the virtual flat. That's my name. Virtual sharp, I can grab these two lines, go to sketch and hit the point tool, and that actually generates a virtual sharp that I can click. and define a dimension. So let's grab select chain, offset, reverse, 1, add caps with arcs. So what that did, so I offset, added the cap with arcs, and that should be fully defined. No, I don't think this needs to be sheet metal part either. Joseph asking, do you prefer top-down assembly or bottom-up? Honestly, it's very situational. I think I do find myself doing top-down more often than bottom-up, though. But bottom-up, you know, sometimes you just want to keep something simple. You want to focus on something and not have like everything around. So, you know, I wouldn't say use one over the other. But yeah, let's say top-down if I had to pick one. And actually there needs to be a hole at the end, I just realized. Oops, I killed my little circle. Yeah, you can, yeah, that's basically what I do. You know, if you've checked, I punched the mic. If you check the past couple of streams, that's basically what I've been doing. You know, it's like, just like the gears from earlier, you know, I was using top down, but then said, oh, but for this, let's just put in its own part file, do it bottom up. So yeah, you don't have to lock yourself into anything in particular. Okay, and we can mirror. Yeah, and handle. Now I can go insert. Get it into place. Get those concentrics in there. Concentric. And then what I'll even say is that the right plane of the assembly, I put those in the same place. Yeah, so since there's no mates between like the thicknesses of the sheet metal, that little discrepancy won't give me any mate errors. But let's do, I need a component mirror for this missing linkage. I always lose, here we go, mirror components. And we want this. And that appears to be correct in terms of orientation. Pretty good. I think these links might be too long. I'm going to take this down to 4. That's better. I can feel the increase in torque by how the crusher moves slower. Yeah, for sure, dude. Yeah, if you move the handle at constant speed, you can see towards the end of its stroke. Oh no. Go back. And very interesting. Let's see how much space I have here compared to... Okay, so this one's a bit shorter. Up 5.5. I think the Amazon listing advertises 7. Well, that's okay. It'll be for short soda cans. Let's put it like that. Save. And yeah, let's put some colors. Some garbage is okay. That gets me. I like the color scheme of this, so I'll probably just copy it. But instead of painted gray, you know, can't go wrong with like brushed steel. On these bad boys. And then, oops, wrong button. And then black on the linkages. Well, I think something I want to do in the future is to try and animate a soda can actually crushing, like kind of how I did the Crash Bandicoot crate bouncing. I showed this earlier in stream. Here, I'll pull it up. Yeah. Basically, if you look at my animation secrets from CAD Model Today thing, I made this crate that bounces in Solidworks. Yeah, this thing. So I'd like to try and make a soda can crush, but I don't think tonight's the night because this as is super involved, and I think crushing a soda can would be even more so. But that's okay because we could still show off the mechanism as is. Yeah, that's true, having a part with no external links. Although you can, in that case, you can have your cake and eat it too. So for example, if you go to edit component to go in context, you can say no external references. And in that regard, like for example, if I try and sketch, and then if I try and reference this, nothing will happen. Like I can still pull that out. Like it'll let me like line it up, but it won't be like stuck there. And then even if I try, you know, control click, yeah, it's just not letting me do it, versus if I do turn on external references, you know, then I can go, and then it actually adds this. Yeah, you can toggle that on and off, which is pretty cool. So it's a ton of control, and I think at that point, it's all about comfort. You know, like, do you like seeing everything else in the assembly while you work, or would you prefer to focus? And I think that's very situational. Set this like this. Get this centered up like that. Joseph saying, I've never used a value solver. How would one of those work? I don't want to say there isn't a value solver. There definitely is. You can use design studies to like find like the perfect value to meet some criterion, like saying, oh, adjust the thickness of this thing until the overall width becomes this, or say keep adjusting the thickness, and you could throw simulation data and say adjust the thickness until the peak stress is under this value, and that's under evaluate design study, but that's another rabbit hole. Yeah, I think I'll leave that one alone for right now. So let me try this. Oh yeah, I guess I didn't put rivets in this thing, but yeah, I think it's one of those nights, especially like I've been streaming for a while now, like over 2 hours. I think we just got to get it done. Ooh, not about that. Oh god, I goofed this. Okay. And I think how I'll configure this motor, it's not constant speed, I'll do data points. And I'll do displacement. So at 2 seconds, do Oculus spline. So from here to here is almost 180. So I'm gonna put like 165, you know, because I don't think it's perfectly that value, you know. So insert row above. Insert row. So let's see how that looks. Yeah, too much. But that is the motion that I want. It looks like it's doing a squat, honestly. So maybe down to 155. Yeah, still too much. I might just jump it all the way down to 135. Yeah, and honestly, this is one of those things that I really should just grab the measure tool and measure in the two positions. It's all good. Okay, that seems fine and dandy. Alright, so let's get this up to 60. Looks like it's having a fun time defining that, or solving for that. Alright, so let me adjust a couple more things. I don't want that red arrow to show, so that's under the eyeball and this motion symbols. So now when I play it, you don't see that red arrow, because I think it's going to confuse people, because it just only shows where the positive direction is, but I don't think it adds anything here. The other thing I'll do is view, display, tangent edges removed. That'll make it look a little bit cleaner. Yeah, the interesting thing is I'm not sure how I want to crop this, because you see the handle goes off the screen. So what I'll do, I'll zoom out like this, replace key. So now we can see the entire handle here.
Recognizing emotion in other people and then communicating that.
The simulation this with a can would be like the bellows system. It would, yeah. I would imagine so, or at least that's the first thing it would try. And if you don't know what he's talking about, I did a CAD model today where there was like a flexible, like a accordion bellows that it was able to animate successfully, you know, expanding and contracting. Yeah, although I would want it to look more random than that, if that makes any sense. And that's what makes it challenging. Alright, it's one of those things I just gotta think about. So this is looking pretty good. So I'll hit this up with an MP4, 60, camera ratio of 1, but instead of just 1280, I'm thinking of tripling this. So high res basically. Let's try that. And this should take some time, because now it's taking, you know, screens that are like triple the size that it normally would like to be. But I think that will help. It'll give me options when I bring this into Camtasia, that if I want to zoom in, you know, it'll still look crisp and good. Or if I just want to leave it like out by its lonesome like this, you know, I have those options. Yeah. So, while we'll wait for this, something I'll do here is, of course, plug my my Discord and my other stuff again. Because I think, the Discord fam is, turning out to be awesome. Here we go. So I take this and copy link location. So again, that is my Discord, and if you want the rest of my social media, you can find it in the link tree. It'll take you here where, this thing will get you where you need to go. But yeah, lots of great stuff happening in the Discord. I actually saved a couple of memes that I want to that I want to post into here that I think will be very, very funny. So let me look at this. I guess you can use the join feature instead of converting all those arts into a sketch. You'll even have auto updating. That's interesting. Yeah, you bring up a great point, Yaya. Let's see. So this thing is still saving out. Honestly, that might be a next stream topic. It's one of those things that I don't think I've used before, I'll be honest with you. But that is a fantastic suggestion. I think it'd be even less computationally expensive because, it's like 200 some lines that it has to convert, so of course that's a huge impact to performance. I think that it's just that whole thing that I did, with the gears. There's also the circular reference, so that won't solve that, I don't think. So there's, it's not my finest work, I would say, but it works. It's a duct tape solution. Alright, so we got to the end, but I have yet to hear the ding. Because ding means done. No ding means no done. So let's see. There we go. That's what I'm talking about. Ding means done. And I can just go to my directory here. And let's check it out. I'd say that's pretty good. The lighting is a little washed out, but I think I'll fix that with the saturation controls in Camtasia. I think we're good with that. So, I think at this point I'm just gonna call it here. This was a long stream, but a good one, because lots of great questions. And I'm glad I'm able to I'm glad I've been able to answer a lot of them and show people a lot of new things. So yeah, thank you for coming out. Again, if you haven't subscribed, I totally recommend you do so if you enjoyed if you like what you see here and you enjoyed yourself. And today, what is today? Tuesday? Yeah, so I will see you in 2 days. Thursday at 7 p.m. Eastern, so basically the same time this one started, 2 days from right now, so 48 hours. I'll see you again with something new, and yeah, can't wait till next time. See you guys.